We do get asked a lot about running costs with infrared. A lot of people are new to the system, haven't come across before. And yes, it's understandably perception is electricity is expensive way to heat your home. Um, just to touch on as well that there's other factors influenced by running costs, and that's level of insulation, ceiling height, number of exterior walls, level of glazing, etc. So when we consult with the client, we'll ask those questions as well. Um, Specifically today, it's talking about running costs. It does vary from house to house depending on how you're using the heating. There's two major ways to use the heating. The way we would recommend is, by the way, we have an application. I'll just show you in a minute of how to look at energy consumption using our system. Actually, let's look at that now. So each controller, the IR Sun controller, is connected to Wi-Fi. So when you come into the room, you have a control pad on the wall and your panel on the ceiling. Each controller is connected to Wi-Fi. You download a free app called IR Sun Regulator. That's it there. Yeah, it's loading there now. Um, and what this does is this records energy consumption. So when you install the system, you put in what you're paying for power, the wattage of the heaters, and it will tell you each and every day how much energy is being consumed. Now, because this is more of a discussion or whatever you want, I'm just going to actually open this as well, just to reference this as I'm talking to you. So the way I use my heating is, and the way we've tested it is, there's two ways. We've tested it, for example, in a bedroom. Do you turn it on in the morning when you're before you get up, and turn it on in the evening when you come back into the room because you're out during the day. So there is the argument that why have the heating on during the day when you're not in the room? We would say that it's better to maintain an ambient temperature being 16, 17 degrees, and don't let the temperature drop underneath that. Why? Because over 24-hour period, if you sporadically turn on and off the heating versus maintaining a base temperature, my base temperature in our rooms is 18 degrees, and then I boost it up from there. Over 24 hours, you will actually notice a similar amount of energy being used compared to turning it on in the morning for a couple of hours and in the evening for a couple of hours versus just having it at 18 degrees all the time. Now, people want different levels of heat. Obviously, the warmer you want your room, the more electricity you're going to use. Here in Ireland, we tend to have 18 degrees in bedrooms and around 20, 22 degrees in our living area. So I'll just show you what's kind of happening. It's very hard to see, but so I have four zones on this circuit, right? It's hard to see there. Four zones. I have a main bedroom. I have one of the kids' bedroom, another kid's bedroom, and the hallway, right? And what's happening is now I'll just go into the main bedroom, and you can see. It's hard to see now. I'll really zoom in on this, right? Because yeah, it's hard to see. Right? But do you see what's happening? I know it's probably turned backside, but you'll see there it's 17.9 the room. The set temperature is 18 degrees, and the panel is using 100 watts. So what it's doing there actually is that to maintain that 18 degrees or 17.9, 18 degrees, it's using at this moment in time 100 watts. Now my bedroom is around 15, 16 square meters. I'm using a 900 watt heater. And at the moment, I have it set at 18 degrees 24/7, and it's currently using 100 watts. Um, how this differs to a standard controller. With a standard controller, so what you'll see is a standard controller is like on and off. So the heater's either blasting or it's off. It's blasting or it's off. So the controller is always reacting to the room temperature. Whereas when you use this IR Sun regulator, at infraredheat.ie, you will see that it modulates. Now, it doesn't, for the technical people, it doesn't actually regulate the heat in terms of current going to the panel. But what it does do is the software inside means that in the background, the panel is either always clicking on or off. So the relay inside is quite big, and that allows more switching over the lifespan of the heater. So with a standard control, you have on, off, on, off, on, off. With a regulator type controller, you're stabilizing and maintaining the temperature of the room. What's the result of that then means that you use less energy and you're not getting that blast of heat. So let's go in now to energy consumption in this room. So we've now determined that at this moment in time, it's 20 past 9 in the morning, and the heater is using averaging 100 watts. Now the outside temperature is 7 degrees. So what you will notice as you, if you like this kind of thing, that on a milder day the heater works less. Obviously, on a winter's day where it's colder outside, the heater works more. And in Ireland, we're looking at 6, 7 months of the year is when the heaters will work more than the rest of the year. So what we do then is we go into day, month, and year. So we can see there that I'll just hit that. So since midnight last night, okay, it's hard to see. Can we zone out? Oh yeah, see it there. It's used 16 cent of electricity, right? So I've configured the app what I spend on it, what my unit price of electricity is, and it's used a half a unit of electricity, right, since midnight last night. Now, during the night, so that's since midnight last night. Then if we go into yesterday, right, I've used in a 24-hour period, I've used, sorry, I'm just trying to see that there, 3.3 units or €1.06. So in a 24-hour period, I've spent €1 in electricity to heat my room. Now, it's a cottage. We refurbished it 2010. There's that much insulation in the floor. Nowadays, if you're building new, you will have 3 times that in the floor. We 50 mil. Regs now is 150 mil. We have 4 inches in the wall, which is pretty standard to what you have now. And then we have a quilt insulation in the attic. So there's no air tightness. So it's a house that it's an old cottage we've refurbished, mass concrete walls. We refurbished it 2010. So compare that to the build now with air tightness, cold bridge, all that kind of thing. The houses now are built more efficiently. So let's look now at the monthly consumption. So far we're nearly in the end of February 2023. We've had mild weather and cold weather this month, and you can see there that I've used 63.8 units of electric, which equated to €20.42. It cost me to heat that room, maintaining 18 degrees all the time, and that's the way I do it. So when you multiply that by other rooms, which I can do, I load all the rooms again. They're all loading there. Now let's have a look at another room. So this room here, it's in an attic space. So it's attic spaces tend to be colder. Well, in my example, because nowadays obviously maybe not because they put airtight membrane in. But mine is just quilt insulation between the timber rafters and slab board to the inside. But you can see here, this is a similar size room, but this room is using 300 watts at the moment. That's a 900 watt heater. So it's using 300 watts. And then we look at daily consumption. So they've used 58 cent of electricity since midnight last night in that room. Now you can see here, look at this one. That room has used €2.37 of electricity yesterday, and a month to date, it used €28. Okay, so for us, that's fine. We're happy with that. That's not bad because I know the property. It's an, as I say, an old cottage. That part of the house, there's a roof space in it. But it's all relevant. But the advantage is that when you are putting out trickling heat from the panel, the surfaces absorb the heat, so they become like the thermal mass, which means the heater then throttles back. So it becomes like a trickling effect of heat into the room. So the panel is ever only working as hard as it needs to work. And that's the great thing about this controller here, that it will record energy consumption. So we give all this information to our clients. Now we have clients that are spending 2,000 a year in electricity, 2,500 a year in electricity. But if you look at those houses, there's a reason for that. The houses might be a C rated. They have the heating going all the time. But this same property, For them to get it, okay, for them to save €500 a year, €600 a year on electricity, they could have to spend 40,000 on the fabric of the building to get it from a C rated to a B or an A rated. And for a lot of people, that's inconvenience. So they're happy to pay the extra €500 or €600 a year, instead of bringing in a builder and spending 40 or 50,000. And that's the reality of it. There's a lot of houses in Ireland that are average insulated that are not, that the cost, right? The cost to get it from that C rating to a B or an A is just not feasible. So the client says, right, we'll put in our infrared panels. The capital cost is a lot less than the alternative, and we're happy to pay an extra 400 or €500, 600, whatever it is. It's all relevant. They're still winning. So that'll give you an idea of what I'm spending on energy costs using my infrared system. And I hope it helps. Have a great day.